Good morning, students. So, in this class, we will talk about one more protocol under data link layer in order to maintain flow control and error control is go back and ARQ. Previously, we have seen one method called stop and wait ARQ. So, in stop and wait ARQ, the problem with stop and wait ARQ is only one frame is sent at a time, and the sender has to wait until next acknowledgement is arrived. So if acknowledgement is not arrived, then the sender is not supposed to send any packet. So that what happens means the total bandwidth is utilized only for one packet, and after successful transmission of one frame, then the sender is supposed to send second frame. So this way there is a bandwidth utilization problem in case of previous method called as stop and wait ARQ. So in order to avoid that problem, we give a flexibility to the sender saying that sender can send more than one frame so that bandwidth of that channel is utilized properly. And when sender sends more than one frame, then again we have a problem of how that acknowledgements are recognized. So now acknowledgements are anyway coming back, but the basic idea behind this go back in is if one acknowledgement is arrived, based on that number, let us say acknowledgement 3 is arrived. So if you have sent already frame 1, frame 2, frame 3 we have sent, but acknowledgement 3 arrived first. If acknowledgement 3 arrived first, then it indicates that already frame 1, frame 2 are successfully received by the receiver. That's the reason we got acknowledgement 3. So this we call it as a group acknowledgement. So instead of having one acknowledgement for one frame, here if you got an acknowledgement with higher number sequence number, then automatically it is indicating a group acknowledgement. If I say acknowledgement 10 is received, it means up to 9th frame it is success. Up to 9th, I am not saying that 9th frame, up to 9th frame all are successfully received by the receiver, then it is waiting for the 10th frame. So that 9 frames can be acknowledged with 9 frames can be acknowledged with only one number called as acknowledgement 10. This way we are going to make use of that channel effectively, the bandwidth effectively. So sender no need to wait, or sender no need to sleep until acknowledgement is arrived at the sender side. So this is the basic advantage of go back N, right? So now you may have a problem like, sir, if packets lost in the middle, we have sent 10 packets, let us say. If 1, 2, 3 are successfully sent, but 4th is not sent, and 5th, 6th, 7th are sent. So in this case, what happens means receiver is capable of taking only one frame at a time. There is no change in this receiver side content, only the change is sender side content. Sender can send more frames, but receiver can receive only one frame at a time, all in sequence, expected one. So now sender is not waiting for the acknowledgement, right? So sender, if he got an acknowledgement with a higher number, that is a group acknowledgement. Now the name go back and indicates if receiver is expecting third one, you have sent 5th one, 6th one, 7th one, then all the frames are simply ignored by the receiver. I repeat, if receiver is expecting third frame is delayed or third frame is lost, but you have sent 4th, 5th, 6th, all these things, then always remembers receiver is going to receive only one frame at a time. That should be matching with the expected frame number. If it is expecting 3, you are sending 4, 5, 6, those are simply ignored. It means whenever there is a problem occurs, let us say third frame is not received, and there is a problem with third frame. So what receiver has to, sender has to do is, he has to go back to that frame number. From there he want to retransmit. That's the reason it is called as go back N. So you have sent 10, let us say sender sent 1 to 10 frames, but there is a problem in 5th frame itself. Then the acknowledgement is received to the sender saying that we have received up to only 5. Then what happens means sender is already at 10th frame, but what he has to do is he has to go back to the 5th frame and he start retransmitting all the packets. That's the reason this protocol is named as go back N. ARQ, automatic repeat request. So in order to implement this concept, see sender side window, I mean how many number of frames we can send means here definitely it is more than one. In case of stop and wait, sender can send one frame and receiver can receive one frame at a time, and after successful transmission of that frame, second frame is sent. So then window size of sender and receiver is only one in case of stop and wait ARQ. But in order to improve the bandwidth channel utilization, bandwidth utilization, we are allowing the sender to send more than one. So then definitely if sender is sending more than one, sender should have more than one sequence numbers. Frame 1 should be given with one sequence number, frame 2, frame 3, likewise there should be more number of sequence numbers. It is not just like 0 and 1 which we have used for the previous method, that is stop and wait ARQ. So in this case, sender side window is divided into different partitions. If you observe this one, let us say we are making use of 4 bits for sequence number. If you are using 4 bits for sequence number, the total available sequence numbers are 2 power 4 minus 1. That is 15 sequence numbers we are using, starting from 0 to 15 sequence. If you have 0 to 15 sequence numbers, now this 0 to 15 band is divided. The 0 to 15 band is divided into 3 categories. So if you observe this one, this band indicates 13 to 14. We make use of again control variables. SF is one, SN is another. SF means it is going to indicate send frame. A frame is sent and waiting for the acknowledgement. These all are the, so SN is set to 0. Meaning of that one is we have sent these frames and then waiting for the acknowledgement. So now in this case we have sent up to 6 frames are sent. So waiting for the acknowledgement. But whereas if you take this one SN, SN indicates sequence numbers which can be assigned to next frames. But frames or packets are not received from the network layer. So these are reserved for what? Next frames. If any packet request comes from the above layer, these are the allowed numbers which are assigned to new frames. So frames that can be sent, meaning of that one is these are the frame numbers which are reserved for the next transmission. So this indicates the frames, sequence numbers which are used for the frames. The frames are already sent but not acknowledged. But if you observe this one, these frames are already acknowledged. See, this SF pointing to this one means we are waiting for this acknowledgement. Indicates we have already received acknowledgement for 15, 14, 13. This way, this band will indicate frames which are already acknowledged, frames yet to be acknowledged, frames can be used, sequence numbers can be used for next frame transmissions. And the other side, if you take those, you cannot use now. Those are not used frames that cannot be sent. So we cannot use those frame numbers as of now because we have already having this total 15 in this band. We have already total 15 in this band. So this way, sender side window is increased. Sender size window size is increased, and this window is partitioned into 3 categories, like the frames which are sent and acknowledged, the frames which are sent but waiting for the acknowledgement, the sequence numbers that can be used for the next coming frame transmissions. Okay. Now the size of the sender size window is always 2 power m minus 1, 2 power m minus 1. And this total window is controlled with 2 control variables. One is SF and another is SN. SF indicates the first frame which is transmitted but waiting for the acknowledgement. So here still, so if 0 is acknowledged, SN is incremented by 1, so that 0 comes under acknowledged list. So we have 13, 14, 15 which are acknowledged already, and when we got an acknowledgement, then SF is moved by 1, so that now we are waiting for an acknowledgement for 1. So now when SF and SN, if both are same, then we are no more not at all waiting for the acknowledgement because all are acknowledged. So if this SF and SN both are reaching to the same point, it indicates that we have not sent anything as of now, and we don't want to wait for any acknowledgement. When a frame is sent, automatically this SN is incremented because Up to this point we have used how many sequence numbers? 6 sequence numbers. Indicates you can use 7 for next. Let us say we have sent 7 also, then Sn is incremented by 1, so 7 comes under this range called as frames sent but not acknowledged. If you send one more frame, 8th frame also we have sent, this Sn is moved to 9 because 9 is the sequence number which can be assigned to next frame. Likewise, this Sn control variable, Sf control variables are used to control how many frames are sent and how many frames are yet to send, how many frames are sent acknowledged. Okay, so if you observe this one, every time that sender side sender window is slided, so sliding window on, we call it as sliding window. Every time when a frame is sent, the window is slided towards right. See, if you see this one, assume that we got acknowledgement for 0th frame, 1st frame, 2nd frame. When we got acknowledgement for 3 frames, automatically that SF is incremented by 3, so that it is pointing to 3, indicates we are waiting for the 3rd frame acknowledgement. We have sent 3rd frame, 4th, 5th, 6th and waiting for 3rd frame acknowledgement. And Sn is still 7, meaning of that one is we have not sent any frames after 6th frame. We have sent up to 6th frame and we are waiting for the acknowledgements, so that even we can send because we have that band. So see this one, this total window is moved. Total window indicates frames yet to acknowledged and the sequence numbers we can use. See this one, now it is pointing to 3 here, na? So the end is what? 1, the end is 1. So these are the sequence numbers we can use for upcoming frames. These are the sequence numbers we can use for next upcoming frames. So this way that total sender side window is divided and its control variables are defined. Okay, in next slide we will talk about design. Receiver side window. Receiver side window is only, receiver capability is only one thing, receiver can receive only one frame at a time, but sender can send many frames at a time. So meaning of that one is the frames are not lost, receiver can receive and immediately it is going to receive next one, next one, next one. So what we are trying to do in this case is we are putting sender in a busy state instead of sitting ideal for waiting for the first acknowledgement. So that is the only change we have in this model. At receiver side nothing is changed. So see here, receiver side window is always 1. So Rn is the one frame to be expected. So now it is expecting 3. Now it is expecting 3. Whenever it come across 3rd frame, then that Rn is moved to next frame. So this way, this total window, receiver side window size is only 1, and that indicates it is pointing, it is expecting 1 frame, and if that frame is received, it is simply incremented by 1. And now by having this Rn, you can categorize these sequence numbers left to this Rn or frames already received and acknowledged, and right or frames that cannot received until that window slides. Meaning of that one is, if you get 3rd frame, then only we are allowed to take 4, 5, 6. If you get 3, then you are allowed to get 4, you are allowed to get 5, likewise. So if you are expecting 3 but you have received a frame called 5, then it is no more use, because always that algorithm works like this. When a expected frame is received, then it is extracted and send it to the above layer. If it is mismatched, we have received a frame but it is not expected, then it is simply ignoring it. Then it is simply ignoring it, and it is not going to change the window to the right side, window to the right. It is not going to slide the window also. Okay, this diagram will show you successful reception of 3rd frame. When 3rd frame is successfully received, that window is slided by 1. So this is about receiver side window in Go Back N Arq. Okay, in previous we have seen sender side. More complexity is there in sender side, because we have given more facility to sender, saying that you can send many frames. When you can send many frames, which are sent, which are acknowledged, which are not acknowledged, all these things has to be addressed. That's the reason that window looks like complex, but with more number of control variables like SF, SA and all these things. Okay, now the total procedure of Go Back N is like this. Right, so at sender side we have already given clear cut information. we make use of control variables SF and SN. SF is the one, the frame, outstanding frame, first outstanding frame in the sense the frame sent waiting for the acknowledgement. SN is the one, the next frame to be sent. Next frame to be sent is SN. When a frame is sent, SN is incremented by 1. When an acknowledgement is received, SF is incremented by 1. So this way, these SF and SN variables are existed. Now we need to understand, we can make use of two flows between sender and receiver. One flow is to send the frames, another flow is to receive the acknowledgements. And you can have multiple acknowledgements in backward direction. You can have multiple frames in forward direction. Multiple frames in forward direction. So now at sender side, data link layer comes into picture, or data link layer will start its activity based on 3 events, as we have discussed in previous algorithm also. One is when there is a request from the above layer, it starts doing the work like prepare the frame and send it. Prepare the frame and send it. And those SN and SF variables are correspondingly adjusted. And similarly, when there is an acknowledgement coming from the physical layer, when we got an acknowledgement from the physical layer, then receiver has to move the window. Receiver has to move the window because we got an acknowledgement. When an acknowledgement is received, that entire sliding window has to be moved right side, right? So that is done when you got a acknowledgement from the other side, that is physical layer. Physical layer will give you a notification saying that we have received one acknowledgement. Now we have a question at this point. If you got an acknowledgement of 5, but you are at a first outstanding frame, then how many number of moves that window has to be moved? When we got an acknowledgement, you are at first outstanding frame, you can move 5 steps, because 5 indicates, fifth acknowledgement indicates 4 frames are received successfully. 4 frames are, see, this window is not moving one by one. This window is not moving in one by one fashion. If we got acknowledgement, advanced acknowledgement, see, let us say the receiver given acknowledgement of 4, receiver given acknowledgement of 5 also. Then acknowledgement 4 is lost in the middle, but we got acknowledgement 5. When you got acknowledgement 5, it indicates acknowledgement of remaining all. That's the reason we call this concept as group acknowledgement. So this way, when we got a higher number acknowledgement, then the window can be moved more than one position also. The window can be moved in more than one position also. Okay. This way, the concept is existed at a sender side. Go back and ARQ. Okay. 3 events correspond similar to the previous one. And here it is only one event. When a frame is received, extracted and given to the above layer, acknowledgement is prepared and sent back. When acknowledgement is prepared, RN is incremented by 1 because next expected one is it is going to indicate. So this way, these two sender and receiver side algorithms are existed. So we will see that algorithms also for the sake of understanding. So here this is an algorithm at a sender side in go back and ARQ. So sender will make use of all these things like what is the window size. Window size is set to 2 power m minus 1, where m is number of bits assigned to sequence. Let us say if you have 2 bits, how many sequence numbers we can have means 0 to 3. If you have 3 bits, you can have sequence numbers 2 power 3 minus 1, that is 7. If you have 4 bits for sequence numbers, you can have 2 power 4 minus 1. This way a window size is calculated at a sender side. Always window size at sender size is 2 power m minus 1, where m indicates number of bits reserved for the sequence numbers, number of bits. Okay. And then we have already said SF means first outstanding frame, which is 0, and SN means next frame to be sent. Both are 0 initially because we have not started our transmission. Continuously, while true means forever, waiting for an event. When a request comes from the network layer, then what happens means it is going to check is window is full or not. If that window is full, then we are not supposed to send. Let us say we have already sent all the frames. We have what is the size of that window? Let us say 15. We have already sent 15 frames and we are waiting for the acknowledgement. No acknowledgement is received so far. Then we are waiting for the acknowledgements for all the 15. In that cases, you are not supposed to send any frame, because we have already sent 15 frames. If window size is full, then no more frames are allowed to send. If you have window size like we are supposed to send 15, up to this point we have sent 3, then you can send still 12 more frames you can send. So in this way it is going to check whether that sliding window is occupied or not. Occupied in the sense all the frames are sent or not. If all the frames are sent, then you are not supposed to send no more frames. So that's the reason it has to wait. So that the first condition is, how do we calculate this whether window is full or not? Means we have two variables, I already told you. One is SF and another is SN. SN minus SF is equal to SW, means SF is at 0, SN is at 15. SF means first outstanding frame which is sent and acknowledged. SN means next frame to be sent is 15. Meaning of that one is that this difference between these two variables is equivalent to sender size window. In that case you are not supposed to send any frame. That's the reason it is going into a sleepy state. And if it is not, then there is a scope to send. In that case we can get the data, we can make a frame with that sequence number and store that one. Why it has to be stored means, again there is a chance of retransmission when there is a fault in the acknowledgement, or if the data is not received properly at the receiver, then we need to resend. That resend is done when that frame is saved. So store that frame and send that frame, and SN is incremented by 1, means next frame to be sent is set to SN. So and now if timer is not started, then we need to start the timer. If timer is not started, we need to start the timer. This way sender side first event is addressed. And next totally 3 events are there. Second event is arrival of the notification. That is when physical layer gives an arrival, like we have received an acknowledgement for the frames, then receive that acknowledgement, check that acknowledgement is properly existed or not. If there is any problem in the acknowledgement, simply ignore it, means sleeper. So silence of the receiver will indicate the sender saying that there is a problem. Sender will not say, receiver will not say anything like my acknowledgement is correct. All these things are never done at this side. So it is simply sleeping. So silence will indicate there is a problem. So, and if acknowledgement is properly existed, and if that acknowledgement number is in between first outstanding frame and SN means next frame to be sent, then only it is valid acknowledgement. If it is a valid acknowledgement, what we need to do is we need to remove that frame, because it is successfully sent. Remove that frame from the buffer, and simply SF is incremented by 1. SF in the sense we have received one acknowledgement, so that we can move that outstanding frame to next position, and then we stop the timer. That is addressing the second event. And the third event is timer expired. So we are waiting for the acknowledgement, but no acknowledgement is received within time. Then what it has to do is, again it is going to start the timer for second time, and in temporary location that first outstanding frame is saved. In temporary location that first outstanding frame is saved, and then it is going to send all the frames. If you observe this while loop, from where we started SF, first outstanding frame, up to where we need to send means SN. So we are going to send multiple frames. Send that frame, increment by 1. How many frames we need to send means where that SF is standard, and where that SN is standard. So the distance between this SF and SN, those many number of frames are retransmitted. Very simple. Okay, this way event timeout is going to addressed. So very simple. When timeout event is occurred, what it is going to do is it is going to check on which frame the time is expired. On which frame? Let us say we have sent 4th frame. We have sent 5th, 6th, 7th also, but on 4th frame itself we have expired the timer. When timer is expired on 4th frame, again the sender has to start the retransmission from 4th frame. Though it has already sent 5, 6, 7, but those are simply ignored by the receiver because it is expecting 4th frame. So that is the reason this algorithm is named as Go Back N Arq. If something goes wrong in the transmission, it is going back to n frames and it retransmits the work. So this way this sender side algorithm is existed. Okay, and if you see this one at receiver side, it is so simple. We make use of only one control variable, that is Rn, which is initialized to 0 when a frame is received and acknowledgement is prepared and sent back, and Rn is incremented by 1. That's what it is doing. How many events are that? Receiver means only one event. When there is a notification from the physical layer saying that we have received a frame, then receive that frame, whether it is corrupted or not, check it. If it is corrupted, don't do anything, and if it is expected one, deliver that data to the above layer and increment that n, that is next frame to be expected, and send that acknowledgement. This is the job of the receiver side algorithm in Go Back N Arq. So it is similar to the previous one, but only changes in sender side, lot of changes are included now. So if you see this one, always we have to remember the window size, whatever is mentioned, it should be less than 2 power m. Window size should be less than 2 power m. It should not be equal to 2 power m. 2 power m. If it is less than, then only we can identify the frames are not running in proper order. See this one. If window size, see the shaded content, we have taken window size as 2 power m minus 1, where m is 2. So we have taken 3. So we have sent 0th frame, first frame, second frame, where Sn is incremented to 3 now, and then it is expecting 0, okay, it is expecting 1, okay, and then it is expecting 2. Rn is at 2 now. When frame 2 is received and Rn is goes to 3, and when Rn goes to 3, see here, no acknowledgement is received. That is the reason SF is standing at 0. And now Sn is sending, Sn is set to 0. This time it is not set to 3. Sn is set to 0. That's the reason frame 0 is sent. When frame 0 is sent, then the receiver is expecting third frame, but we have sent 0th frame. So mismatch, then it is capable of detecting it is not expected, that we need to drop it. It is possible only when we take window size is less than 2 power m. If you have not taken like this, let us say we have taken window size as 2 power m, and then what happens means, in right side diagram you observe, same timer expire period is this. We have sent 0th frame, okay, Rn is incremented by 1. We have sent first frame, second frame, and Rn is incremented by 1. Likewise, we have sent frame 3 also. When frame 3 also accepted, okay, and when frame 3 is accepted, Rn is set to 0. Now, if you observe in this case, we have sent how many frames? Up to 3 we have sent, and that is expecting 0th frame. But as per our logic concern, this Sn, that is 0th frame is not we are not supposed to send 0th frame, because the size is what, 4. So 0 to 3 only we are allowed. So Sn is set to 0. When Sn is set to 0 and the frame to be expected, the receiver is again giving an acknowledgement saying that we require 0. So 0th frame is sent and it is accepted. So it should not be accepted, because we are not supposed to send this 0th frame. Because this frame is already filled, so it is not get any acknowledgement, so that it has to be ignored. So but as per this algorithm concern, it is not going to ignore directly, it is going to accept. Frame 0 it is going to accept, but frame 0 is already received and it is again receiving the same, in order to avoid that one, again receiving the same frame. In order to avoid that one, see this, up to this point only it is going to stop, that is n minus 1, 3 frames only send. If you send like that, then only there is a mismatch. Frame 0 is sent, but it is expecting R3, then it is going to realize frame 0 is already received and I am expecting frame 3. So likewise, window size is decided in ARQ with the help of a formula called, it should be less than 2 power m. It should not be equal to this one, 2 power m. If it is equal to 2 power m, the receiver is not capable of understanding that frame is already received. So it is going to accept it because of this error. So it is not possible to implement this method if you consider window size as 2 power m. It should be less than that. So if you see this one, it will indicate flow control. A small example demonstrated. So we start the timer Initially SF, SN is there, so 0, both are at 0. We have sent 0th frame, okay, it is received, and RN is incremented by acknowledged. If you observe these points, SF also incremented. See this, SF is pointing to 1 now because acknowledgement is received. That's the reason SF is moved. When SF is moved, the total window is slided. The total window is slided. Likewise, when we send frame 1, okay, frame 1 is expected and that is received, and RN is expecting 2. But acknowledgement is lost. But we are not stopping our work, like we send frame 2, and when frame 2 is received here, so RN is 2, so that frame 2 also accepted, and RN is set to 3, and then frame 3 is set, and RN is set to 4, and which acknowledgement is given? Fourth acknowledgement is given. When fourth acknowledgement is given, and automatically that SF, outstanding frame, acknowledgement, see we lost acknowledgement 2. Though you have lost acknowledgement 2, acknowledgement 3 is used for indicating this second frame also received. Acknowledgement 3 indicates up to 3 we have received. So though you have lost acknowledgement 2, it is not going to do any retransmissions. Okay, and when we send remaining frames, all the remaining frames are received properly. Frames are received properly. If there is a loss of acknowledgement, that acknowledgement can be addressed with the help of higher number acknowledgement. Acknowledgement 2 is lost, but we have given acknowledgement 3, right? 3 indicates acknowledgement 2 also included in this. 3 received means up to 3 we received. That's the reason, though you lost 2, see when receiver will give 3, as RN is come across 2, that is the reason it is giving 3. So that don't worry about this loss of acknowledgement 2. It is addressed with the higher number acknowledgement. This way, acknowledgements are used for group acknowledgements. One acknowledgement can address many frames. Okay. So frame itself lost. Frame 0 is sent. Okay, acknowledged. Frame 1 is sent. When frame 1 is sent, see this one. Frame 2, frame 3 are sent. As we are having enough space or enough sequence numbers, frame we sent, it is lost, not acknowledgement, frame itself lost, not received. So what is expected by this receiver means only first frame. You have sent frame 2, so it is ignored. See, RN is not moved. Frame 3, RN is not moved. Now, what happens means up to this point, timer is expired. Which timer? First frame timer is expired. When first frame timer is expired, what is the job of the sender means? It is going back to that first frame and starts retransmission. Go back N, starts retransmission, then all the frames are received. So this way, if it is expecting one frame and you are sending other frames, those are not considered and simply ignored. And whenever the timer is expired for the last frame, then it is going to start a retransmission. So it may be a problem. It may be a problem in this method. So for example, we have sent 9 frames. First frame itself lost. Then 8 frames are successfully received, but those are not considered, simply dropped. So this is a problem with the go back N. There is an alternate for this one, selective repeat. That algorithm we will see in next class.